1.6 is called Trig. A couple of years ago, I'd say going on 3 years now, I had two girls that decided they didn't want to take Trig before they took calculus. And they found out they had lots of problems that they didn't take Trig before calculus, because calculus is not solely on Trig, but sparingly we come across trigonometry, and it'll be the non-calculator section on the AP test, and you have to know how to do Trig without relying on your calculator. So you need to do this section without relying on your calculator, so don't even rely on it. What we are going to do in 1.6, in only 5 templates, or maybe a little bit more, I think it's only 5 templates, maybe 6, is we're going to do all of it except maybe one section. We're going to do all of trigonometry in one section. We're going to review all of trig in one section without using a calculator. And after I taught this section in calculus a couple of years ago, those two girls were in tears because I went way too fast for them. But I think that everybody who's taking calculus has taken trig, so I can go fast in this section because everyone's had this last year, and we had a whole semester of this class. So we're going to learn how to review all the trig functions. So basically, this is a 30, 60, 90 triangle, and this is the 45, 45, 90 triangle. This is what you learned at the beginning of trigonometry. The side opposite of 30, remember, is a 1. The side opposite of 60 is the root 3, and the hypotenuse on a 30, 60, 90 triangle is a 2. On a 45, 45, 90, it goes 1, 1, root 2. Very, very important that you know this for calculus for next year. You also have to know that the sine is y over r, cosine is x over r, tangent is y over x, and they're reciprocals. So here we go. Let's just review trig in one section. Solve without a calculator. We did lots of this last year, lots of it. I even gave you a summer packet on how to do this. So the first thing you're going to do is draw where 240 lands. Well, 240 is not 90, it's not 180. It's somewhere in the third quadrant, and I draw where I think 240 is. You draw a line to the x-axis, if you guys remember this from trigonometry. I went past the 180 marker by 60 degrees. I know I'm dealing with a 30, 60, 90 triangle. Opposite of 60 is a negative root 3, though. A negative because you're in the third quadrant. Opposite of 30 is a negative 1, and the hypotenuse on this is a 2. I know that tangent is y over x. My y is a negative root 3, and my x is a negative 1. My final answer for this problem is root 3. This should not look Greek to you. You should definitely know how to do this without a calculator. What is the cosine of 90 degrees? Well, 90 degrees is right here. This does not make a triangle. This point here is called 0, 1. The radius of this is also 1. The formula for cosine is x over r. Well, my x is 0 and my r is 1, which gives me 0. And then the last one, 135 degrees puts me in my second quadrant. I know I'm dealing with a 45-degree triangle. Opposite of 45 is a 1. Opposite of the other 45 is going to end up being a negative 1. And the hypotenuse is root 2. I know that this is the reciprocal of cosine. So it's r over x. The radius is the square root of 2. And the x is a negative 1, which ends up being a negative root 2. I gave you a worksheet to do in the summertime, so you should be pretty good at part 1. Part 2, how do you go from radians to degrees or degrees to radians? So there was 2 ways you could have done it. A lot of you know that pi over 4 is 45 degrees. A lot of you know that pi over 3 is 60 degrees. A lot of you know that pi over 6 is 30 degrees. And pi over 2 is 90 degrees. You can do this 2 ways. 3 pi over 4, you know, is 45 degrees. How many 45 degrees? 3 45s. And 3 45s make 135 degrees. That's one way. That's the way I would do it. If you don't want to do it this way, you can multiply it by 180 over pi, because 180 and pi stand for the same thing. Cancel out the pi's. 3 times 180 divided by 4 is 135. So that's another way you can do it. Like 2 pi over 7. I don't know that one. It's not one of my, for the 6 or the 2. This is a 7. So I'm going to do it the old-fashioned way, 180 over pi. Get rid of the pi's. 2 times 180 is 360, and 360 divided by 7 is going to equal like 51.429 degrees. You're going the opposite way. 48 times pi over 180, which is 48 pi divided by 180. And let's see, I think a 4 goes into both of these. 4 goes into 12 times. 4 goes into here 45 times. Now 3 goes into both of these. 4 pi over 15. 4 pi over 15 in reduced form. So, arc length. The slice of pizza has a radius of 5 inches and an angle of 72 degrees. Find the length of the crust or arc length. This is the formula for arc length. Arc length is the S equals the R and the theta. Well, they give us the radius of 5 and they give us the angle of 72 degrees. And all they want you to do is figure out, well, here's a slice of pizza. Here's 72 degrees. And the radius of this pizza is 5 inches. They want to know how much crust is here. So S stands for arc length, so you're just going to put S down. You know what your radius is 5. And if you put 72 down and you do 5 times 72, everybody do 5 times 72, you're going to get 360 would be the inches of the crust, and that doesn't even make sense. It can't be 360 inches when the radius of this pizza is 5. 1 radian in trig, I'm hoping you remember, is 57.3 degrees. You cannot use 72 degrees. You have to take 72 and divide it by 57.3, which gives you 1.25. So you're going to put 5, and in place of the angle, you're going to put in 1.2565 and so on. You're going to multiply that by 5, and you're going to get 6.283. You go out to 3 decimal places. That's how many inches the crust is. Does that make more sense that the crust would be 6.283 inches long instead of doing, you got to know that 1 radian is 57.3 degrees. Okay. Now we're going to go the opposite direction that you learned. This little -1 means you have to find the angle given the fraction. We're going to deal with the principal values of a trig inverse. The sine inverse, remember the principal values that you learned in chapter 6, section 8. In your trig book, I even remember teaching this, chapter 6, section 8, that you're going to use these 2 quadrants because sine is positive in this quadrant and negative in this one. Cosine, you're going to use these 2 quadrants. It's positive in this quadrant, negative in this quadrant. And tangent, you're also going to use these 2 quadrants, positive and negative. So, we're going to draw ourselves a picture. We know that the sine means we have to find the angle because there's a little -1. We know that it's a positive, so we're going to work in the first quadrant, and we're going to make ourselves a triangle. And we know that this is y over r, so we know that the y is the square root of 3. We know that this is 2. We know the side opposite of the square root of 3 is 60. You found your answer. You can either write it as 60 degrees. On the AP test, though, they like it in radians, so pi over 3. Cosine inverse. Again, you're trying to find the angle. Well, cosine is negative in the second quadrant. If you look at this, it's really 1 over root 2 to start with, a -1 over root 2, and then it ends up being a negative root 2 over 2 when you simplify it. Well, whenever you're dealing with a root 2, you know that you're dealing with a 45-degree triangle. And if you're in the second quadrant, you know you're dealing with 135 degrees for your answer. Tangent inverse. Well, tangent is negative in this quadrant, so I'm going to make a negative. We know that tangent is y over x, so the y's and the x's have to be the same. So we're going to put a 1 here and a -1 here. Well, this has to be the square root of 2. We're dealing with a 45-degree triangle, which is a -45 degrees, or a -pi over 4. Because the stipulation says you have to go from a -pi over 2 to a positive pi over 2. A -pi over 2 to a positive pi over 2. And 0 to pi are the stipulations. That's why I can't say 315, because it has to be between that stipulation. Okay, solving using your graphing calculator one more time. Tangent of x is equal to 2.5. You're trying to come up with where your tangent of x is equal to 2.5. I'm going to go back and use my y1 button and my y2 button. Make sure your calculator is in radians when you're dealing with calculus, though. I told you calculus usually work in radians. So go under mode and look to see if your calculator says radians highlighted or degrees. Make sure your calculator's in radians. Okay, once I went under mode, I'm going to go under y equals, and under y equals, I'm going to clear everything under y1 and y2. This is, how many times have we used the y1, y2 button? Many times already. Under y1, I'm going to type in tangent of x. And under y2, I'm going to type in 2.5. And I'm going to graph. And when I graph, you guys, this is what I get. I get a snake, and a snake. And then I see a horizontal line, which would be this one right here. As you can see that there's 3 answers to where it intersections. You have to type this in also. This is the window that you want to do. So let's go under window. Everybody go to window. And I want my x-axis. This stands for x, so I want to start at 0. And I only want to go to 2 pi, so type in 2. And the pi button is above the caret button. Everybody see the caret button? Type in 0 to 2 pi, and now hit graph again. And it's going to only give me from 0 to 2 pi. And you're going to see that it only intersects now. This is what my picture looks like. And it only intersections at 2 points. So I'm going to hit second calculate, and I'm going to hit intersect. And I'm going to move my cursor to my first spot where I think it intersects at. And it intersects at 4.332 is this one. I'm going to hit it again, second calculate, and I'm going to hit intersect again, and I'm going to arrow over to my other graph by just using my arrow buttons, and then hit my enter, 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 and now it's highlighted over here, and I'm getting 1.190. So those are my 2 answers where the tangent of 1.190 and the tangent of 4.322 equals 2.5. Okay, let's do the same thing with this one. Make this y1, make this y2, change your window. Let's see if you guys can handle doing this again. And then I think we're done with notes. Oh, we have some graphs to do. I'm not done with notes, sorry. Under y1, I'm going to put the sine of x. Under y2, I'm going to put the square root of 3, 2. So I'm going to go under alpha f1 to find my division and do the square root of 3 over 2. And get rid of that. Alpha y equals, which is alpha f1, will help you find your division thinking thing. It's used a lot in this class again. Hit the graph button. My window's already set from 0 to 2 pi, and you can see that they intersect. It looks like this. It's already set from 0 to 2 pi, and they intersect here, and they intersect here. I'm going to just zoom decimal. It doesn't matter, whichever way you want. You can do whatever you want, but it's going to be those two spots. And let me just finish this really quick here. I want to figure out what the answer is here. 0 to, I'm changing my window from 0 to 2 pi for my x values, and I think I'm going to change it from 0 to 10 for my y value. No, 0 to 5. 0 to 5 for my y value. I'm going to go a little higher, 0 to 5. I'm going to go back to my window and change it to 0 to 8 for my y value. I'm going to change it to 0 to 20 on my y value. See how I'm playing around with this? That's just flattening it out more. So I'm going to go 0 to 3, 0 to 3. My window, I'm going to change it to 0 to 3 and see what it does. Way better. See how I'm playing around with it? These are my y values, these are my x values, and as I went up, it flattened out my graph, obviously. So I just wanted to show you how I was playing around with it. Second calculate, intersect. I gotta move my cursor to my first spot, and I'm going to get for my first answer 2.094, and I'm going to do second calculate again, intersect, and I'll move my cursor to the other side, other one, which is equal to 1.047 are my two answers for this one. So. Okay, the last part, I guess we have a couple parts left. I think this might be the last page. Yeah, we're just showing you how to graph. So graphs of sine and cosine functions and tangent functions. You did this. This was chapter 6 last year, you guys. The period for sine and cosine is 2 pi. The period for tangent is pi. Keep that in mind. So, what does a cosine graph and sine graph looks like? Remember when we did sine graphs, we needed 1, 2, 3, 4, and the last one was 5. Cosine, you needed 1, 2, 3, 4, and the last one is 5. Tangent, you needed 1 on each side. You guys remember that? Remember that this stands for 2 pi. This stands for pi, pi over 2, pi over 2. And this is pi over 2 and a negative pi over 2. I'll wait for you guys to catch up here. There's a little imaginary 1 in front of the x, and that's how we got 2 pi divided by the amplitude, the k. 2 2 pi divided by k, and the k is 1, and that's why we went out to 2 pi. We go, sine starts at 0, goes up, comes down, and comes back up. It has a little hill and then a valley. Cosine starts at 1, goes down, comes back up. This is what a cosine graph looks like. And a tangent graph has an asymptote at there and an asymptote here, and it makes a snake. We spent a whole chapter 6 on how to graph sine and cosine and tangent graphs. Again, the period for sine and cosine is 2 pi divided by k, and the period for tangent is just pi divided by k. So, last page, let's go through 4 of these. How do you graph the sine of 3x? So I know I need 1, 2, 3, 4, and the 5th one is 5. This is fast. I know there's an imaginary 1 and a negative 1. And I know that this stands for the period, and to get the period, it's 2 pi divided by 3. That's what goes right here. 2 pi divided by 3. A half of 2 pi over 3 is just 1 pi over 3. And if you know that pi over 3 is 60, you know that this is 120, and you know that each one of these is 30 if you know what you're talking about. You know that sine starts at 0, goes up, down, and up. And you are done. I graphed one cycle from 0 to 120 degrees. It's fast, but you spent a whole semester on trigonometry. So you should be pretty good at how to graph a trig function. Tangent. Remember, tangent only has 1 on this side and 1 on this side, and you know that it makes a snake like this. But I need to label these. There's a 3 here, and for tangent it's not 2 pi, it's pi divided by 3. And if you know pi divided by 3 is 60 degrees, you know from here to here makes a full 60 degrees. This needs to be a positive 30, and you know that this needs to make a negative 30, so the whole thing takes 60 degrees. Okay, now comes the shifting of the graphs. So these are the big ones here, and you have to know how to do this without a graphing calculator. 1, 2, 3, 4, 5, 6. We're going to put a bunch of them, and we are going to do the same thing. 1, 2, 3, 4, 5, and we're going to put some over here too for this one. Okay, so the first thing you're going to do, it's been a while, but you're going to graph this first. Y is equal to 2 cosine of 2x. I'm going to go up 2, and I'm going to go down 2. Why? Because that is my amplitude, is 2. My 4th slash right here is called my period. And how do I get my period? It's 2 pi divided by 2, which ends up being a pi right there. Pi is 180. This is pi over 2, which is 90. And half of 90 is 45, so I'm counting by 45 degrees. And all I'm going to do is graph this. And I know that cosine starts at the y-axis, comes down, goes up, and goes up. So that little bubble, if I connected the dots, would be 2 cosine of 2x. But I got to shift all those dots. And there's a negative sign, so I'm going to shift them to the right, because negative means shift to the right. And this is the mistake that some people made last year, but you're a calculus student, so you probably wouldn't have made this mistake. You're going to shift everything not to the right pi. It's this one divided by this one. So you're going to shift everything to the right, pi over 2. Don't forget to take these two, c divided by k. C divided by k. This is the c value, this is the k value. You don't just shift it to the right pi, you shift it to the right pi over 2. Pi over 2 stands for 2 slashes, you guys. You're going to move everything to the right 2 slashes. So this dot goes here, this dot goes here, this dot goes here, this dot goes here, and this dot goes here. This is the answer to the problem. Okay, let's do this one, and I think we're pretty much done graphing sine and cosines and everything else. That's it. You can't do these on your calculator. You have to be able to do these on your own. So make sure you make your own graph. So how do you make your own graph? I am only gonna do this part first, and I'm gonna put 5 dots on this graph. And I know that my amplitude is up 2, and I know my amplitude is down 2. I'll talk about the negative sign later. I know that this stands for my period, right there, the forward slash. I take 2 pi, and I divide it by a half, the k right there, and I get 4 pi, so this ends up being 4 pi, this ends up being 2 pi, and I know I'm counting by pi's then. Okay, I'm not graphing a cosine graph, I'm graphing a sine graph. All sine graphs start at 0. But what does that negative sign do to the graph? Do I go up or do I go down first? I go down, I go up, and I go back down. I could connect these 5 if this was the answer, but I'm going to shift all of these. This makes a vertical shift, if you remember a while back. And your horizontal shift is pi divided by 2 divided by 1/2, which is pi divided by 2. Flip this to 2/1. I'm going to shift everything to the left pi. Everything gets shifted to the left pi and up 2. So this is what every dot's going to, I'm going to go left pi. Well, pi is only 1 slash, you guys. So I'm going to go 1 slash to the left, and I'm going to go also up 2. So that dot went to the left 1 and up 2. This dot goes left 1 and up 2. Left 1 and up 2. Left 1 and up 2. And left 1 and up 2. This is my new graph, and they always, you can put your horizontal asymptote up there. If this wasn't enough notes on how to graph, you can re-watch the notes if I went too fast, or you can Google and YouTube how to graph cosine and sine graphs if you don't catch on to this. You can look back at your notes. Hopefully you kept your notes from last year for trigonometry too.